Hello everybody and welcome to the video on section 5.7 Rational Exponents. Make sure that you take any notes and answer the survey questions at the end. So, rational exponents and radicals. Squaring a number and taking the square root are inverse operations. This is something that we learned before we talked about inverses. This is something that we need to remember now. So, for example, when we have the square root of x and we square it, we get x. The square and the square root cancel each other out. What do we do if we have a fractional exponent? So we haven't really talked about this yet, but what do we do about that? So for example, if we have b to the 1/2 and raised to the second, what does that mean? So that equals b to the 1/2 times b to the 1/2, because when we raise something to the second power, we multiply it by itself. Okay, so we can simplify this using our properties of exponents. When we multiply two powers, we add their exponents, so we get b to the 1/2 plus 1/2. Remember, 1/2 plus 1/2 is 1, so b to the 1 or just b. So b to the 1/2 is a number whose square equals b, or b to the 1/2 equals the square root of b. So b to the 1/2 and the square root of b are the same thing. So in fancy math terms, for any real number b and for any positive integer n, b to the 1 over n equals the nth root of b, except when b is less than 0, so a negative number, and, keyword there is and, n is even. So b cannot be negative while n is even. That's very important. Okay, now let's look at an example. So write each expression in radical form. So here's our first one. Okay, that's not a negative, that's a bullet. So let me pull up my pen here. We'll do this in blue. Okay, so a to the 1/4. A to the 1/4 is the same as the fourth root of a. Simple enough. Let's look at our next example. X to the 1/5. X to the 1/5 is the same as the fifth root of x. And that's pretty much it. Simple, down to earth. Okay. So let's look at another example. So basically, just take it and go the other direction. So write each radical using rational exponents. So first one, the third root or cubed root of y is the same as y to the 1/3. Okay, let's look at another one. The eighth root of c is the same as c to the 1/8. Okay, pretty simple. Now, let's take it one step further. Evaluate the expressions with rational exponents. So evaluate the expression. Now we have two ways that we can do this. So let's look at the first one. So we have 16 to the negative 1/4. So there's a couple ways we can do this. Remember to use your exponent rules. So our first thing we can do is, remember, when we have negative exponents, we take it to the other side of our fraction. So since it's on top right now, we're going to bring it down to the bottom. So we get 6 to the negative 1/4 becomes 1/16 to the 1/4. Okay? Okay, so that is the same as 1 over the fourth root of 16, which is what we just learned. Now, what is the fourth root of 16? So you can either do this in your calculator, like you could do 16 to the 1/4, or you can remember that 16 is the same as 2 to the 4. Now, if you recall, we talked about how square roots and squares are opposites, are inverses. So fourth roots and to the 4th powers are also inverses. So they cancel out, and what we're left with is 1/2. Now, onto our second method, which is pretty similar, except it takes another route. Okay, so we start with the same 16 to the negative 1/4, except we're going to take that and immediately make it 16 is the same as 2 to the 4th raised to the negative 1/4. Okay, now we're going to remember our exponent rules, and remember that when we raise a power to a power, that we multiply our exponents. So from that, we do 4 times negative 1/4, which, if you recall, equals negative 1. Okay, So then our last step is we're going to get rid of the negative exponent because we don't want any negative exponents. We're going to bring it to the other side of our fraction bar, which gives us 1 over 2. And there you go. So I can move on. So one more rule, one more fancy rule in math words. For any non-zero real number b, and for any integers m and n, with n greater than 1, m or b to the m over n equals the nth root of b raised to the m, which equals the nth root of b raised to the m. Okay, so basically we can take that m and either have it on the inside of the inside of the root or on the outside. It doesn't matter really what we do first. Okay, this only works if b is as long as b is not less than 0, so not negative, and when n is even. Okay, so remember that n is important here. Okay, so our example, 8 to the 2/3 is the same as the cube root of 8 to the second, or the cube root of 8 raised to the second, which also equals 4. Now, wrapping it up. All properties of powers that we learned in the first section of these units still apply. Okay, so that means like multiplying powers, raising power to a power, dividing powers, etc. So we kind of talked about this already. Use these properties in order to simplify some expressions whenever you can. An expression with rational exponents is simplified when all the following conditions are met. First, it has no negative exponents. Second, it has no fractional exponents in the denominator. Third, it is not a complex fraction. Fourth, the index of any remaining radical is the least number possible. When pretty much what that means is that little number has to be that little number on a root has to be the smallest that it can. So we don't want to leave it something huge if we don't need it to be. Okay. Here are your survey questions. Please read through them. Have any questions ready for us when you come into class.